AB and CD are two parallel chords of a circle with center O. AB equals to 30 cm, CD equals to 48 cm, and the perpendicular distance from O to AB is 20 cm. Find part A, the radius of the circle, part B, the perpendicular distance between AB and CD. So in this diagram, we are given a circle where AB and CD are two parallel chords on the circle. The length of AB is 30 cm, CD is 48 cm, and this perpendicular distance from the center of the circle to the chord AB is 20 cm. And we want to find two items, part A, the radius of the circle, and part B, the perpendicular distance from the two chords AB and CD. Now what we'll do first is to draw the radii OA and OC, which will look like this. Since that O is the center of the circle and A and C are points on the circumference, these two dotted lines here, OA and OC, will be the radii of the circle. We'll next draw a perpendicular ON from the center O to CD. So this line ON will be perpendicular to CD. And as for the other perpendicular line from O to AB, we'll label this intersection here M. Observe that these two angles, OMA and ONC, are both right angles. And since the two chords AB and CD are parallel, this will make MON a straight line, as these two angles add up to 180 degrees. They are interior angles. So to find the radius of this circle, we'll focus on this triangle OAM. The length of AM will be half the length of AB due to the property that perpendicular lines from the center will bisect a chord. So AM will be half of AB. AB is 30 cm, so half of 30 will give us 15. The length of AM will be 15 cm. So in triangle OAM, we have the lengths of two sides of the triangle. We can use the Pythagoras theorem to find the length of OA, which is the hypotenuse. So OA square will be equals to the sum of squares of the other two sides, AM square plus OM square. So AM is 15, OM is 20. We'll have 15 square plus 20 square. Evaluating the right side of this expression and taking square roots on both sides, OA will be equals to the square root of 625, which will give us 25. So OA will be equals to 25 cm. So hence, the radius of this circle is 25 centimeters. Now moving on to part B, we have to find the perpendicular distance between the two chords AB and CD. And as mentioned, the perpendicular distance between the two chords will be the line MN. Observe that from the diagram, the line MN consists of two parts, MO, which length we already know, and ON. Now from part A, we have found that the radius of this circle is 25 cm. So the length of OC, which is also the radius of the circle, will be 25 cm. So since that CD is a chord of this circle and ON is perpendicular to CD, we can first find the length of CN, which is half of this length of CD. So in triangle OCN, CN will be half of the length of CD. From the question, CD is 48 cm, So half of 48 will be 24. So CN here will be 24, and likewise the length of ND will also be 24. So in this triangle OCN, we now have the length of the hypotenuse 25 and the length of CN, which is 24. We can find the length of this last side ON. So OC square, the hypotenuse square, will be the sum of squares of the other two sides, CN square plus ON square. So again, this is the Pythagoras theorem. Substituting OC with 25 and CN with 24, we'll have 25 square equals to 24 square plus ON square. Simplifying this equation, we'll have ON square equals to 49, so ON will be equals to 7 cm. So to find the distance of MN, which is the perpendicular distance between the two chords, we'll take MO plus ON, which will be 20 plus 7, giving us 27. So the perpendicular distance between AB and CD will be 27 centimeters.